Okay, chapter 7.1, and this is more solving equations with a little more tricks in them. Okay, we're going to use some of those identity to switcheroo and some tricks. Okay, so first of all, the first type of problem is we have 2 sine squared t plus sine t. It's set equal to 0, and I'm noticing that they both have a sign, so one of your tricks is going to be to factor. Okay, so they both have a sign. There's just two terms here, so I'm going to take a sine of t out, and I'll have a 2 sine of t plus 1 equals 0 left. And then once it's factored, I can set each of these equal to 0. So sine of t equals 0, or 2 sine of t plus 1 equals 0. And so I find what angle has a sine of 0, and just look at your unit circle and think about it. Okay, sine is y-coordinate. So the y-coordinate would be 0 at 0 and pi. So t equals 0 and pi. Now over here, minus the 1, divide by 2. So which angles have a sine of -1/2? And I'm going to look at my unit circle. Sine is my y-coordinate, so it's negative, so it's down here, and that's my shorty, so it's going to be the short y, so I'm going to be going out here and here. And so this is my pi, which is 6 pi over 6, so this is 7 pi over 6, and this is 12 pi over 6, so this will be 11 pi over 6. So those are my two answers over here. Now I check to see, do they want all of them or just between 0 and 2 pi? And the answer is between 0 and 2 pi. So my answers are 0, I could put them in order if I want or not, pi, 7 pi over 6, and 11 pi over 6. And you can see, oh look, here's my 0, here's my pi, 3.14, here's my 7 pi over 6 is going to be a little bit more than 3.14, as you see over here, radians. And by the way, these are the answers in radians. 11 pi over 6 is going to be really close to the end of the circle, which is 6.28 radians. So you can see my skill. All right, so nice to check it. If you do put these in your graphing calculator, make sure your mode is in radians. And you can also check it on desmos.com. All right, let's look at another example. Here's our secant function. We've got 3 secant squared t minus 5 secant t minus 2. Okay, that looks like a trinomial, and I'm going to think of secant as x. So 3x squared. So my secant t is going to be my x minus 5x minus 2. So if you can think of solving a problem like this, and thinking as, oh, x is really secant of t. And now I have secant t squared would be x, okay? So then let's factor this. So 3x and x, 2 times 1. If I put the 2 in here, then I'd have to add the 2x and the 3x, and I can't because one has to be positive and one has to be negative. So I'm going to put the 2 out here and the 1 here. That way I have a 1x in the middle and a 6x, and I need a -6 plus 1 for my -5x. Okay, let's set each of these with the secant back in. So 3 secant of t plus 1 equals 0, and then regular secant of t minus 2 equals 0. And then let's solve each of these. Divide by 3. Secant of t equals -1/3. Well, if the secant is -1/3, that means that the reciprocal, which I really know much more about, is -3. Now, the cosine of an angle, the domain of that is 0 to 2. Wait, we're on 0 to 2 pi, but the range of that is 1 to -1 on a cosine graph, if you think about it. And on the unit circle, your cosine is never more than 1 or -1. So there's no solution. There is no angle that has a cosine of -3. All right, so let's take a peek at this one. Put the 2 on the other side. and I have secant of t equals 2, well, that means that the cosine, which is the reciprocal of 2. Now that, I know we have cosines 1/2. So cosine is the x-coordinate, so here's my 1/2. So that's going to be up here and down here, because these are negative cosines. We don't want those. So that's my pi over 3, and this is my almost 6 pi over 3, so that's going to be a 5 pi over 3. So my two answers are pi over 3 and 5 pi over 3. Let's see what the next one has. Oops, not too many. Okay, there's a try it now I thought I would do with you. It's very similar to that, okay? And so we're going to factor that as soon as I open this back up. Okay, so let's stop the meeting here.